I promised to do a video demonstrating how to perform kind of all of the essential descriptive statistics calculations in Excel because it's much faster and easier to do it with this software than it is to do those calculations by hand. So I've got in front of me a set of randomly generated data here. You can see that I've got a total of 58 data points, and I'm going to use that sample that's there to calculate the mean and standard deviation and whatnot. I guess I won't call it a sample. I'll say set of data because we'll try treating it as both a sample and a population just by way of demonstration. So let's suppose that I want to go ahead and calculate the mean, the arithmetic mean of this data. The arithmetic mean, of course, just being the one you're used to, where you add all of the observations together and then divide by however many you happen to have. If this is a sample, this would be called X bar. If it's a population, it'll be called mu. But we know regardless that the calculation process will be the same. It's really just a difference in the name and the symbols used in the formula. In Excel, when you want to calculate a mean, you're going to find a cell that you can type in, and you're going to start with an equal sign to indicate that you'll be putting in a formula or a function. And the function for calculating the mean is just the word average. So most people call an arithmetic mean the average, and that's the name of the function in Excel, so it's very easy to remember. You type the word average and open parentheses, and then you select all of the data that you would like to average. So you can click and drag here, or you can click on the first cell and use that little Control Shift and then arrow keys trick that I talked about previously. Whatever works best for you. You can also type A1 colon B29 into the cell to get Excel to select the range for you. Regardless, once you've selected the range, press enter, and you now have the mean. So X bar is 25.66 if this is a sample of data. If it's a population, then then mu is 25.66, right? So same number, just different names. If we want to go ahead and calculate the standard deviation, then it's going to matter whether we consider this set of data to be a sample or a population. So I'll write here standard deviation, and I'll put if sample. And below that, I'll do standard deviation if population. And you'll see it's really a minor change that we have to do in terms of performing the calculation. So in Excel, the formula for a standard deviation is STDEV or STDEV. And you'll notice that as I type in a formula, Excel pops up with all these suggestions. So quite often, oops, kind of lost it there. Quite often as you're typing, you can check the list and see if something comes up. If you don't know the formula, you can just kind of take a guess and see what it suggests. So if you started typing the word standard, you'd get to ST, and then you'd see like standardize, STDEV, STDEV.S, and all these different things. And you can look at each one, and it'll give you a little description of what they are. So I type STDEV. And then you'll see there's two options, .P and .S. I'm going to use .S for sample. So STDEV.S, select your data, close your parentheses, and wham, you're done. 12.08 is the standard deviation of this data set. If it's a sample, heck of a lot faster than calculating the mean and then going 32 minus 25.7 plus squared plus 28 minus 25.7 squared plus 25 minus 25.7 squared, and so on all the way along, adding those all together, dividing by, I think it was 57, excuse me, because n minus 1, and then square rooting all that, right? That would take a very long time. If this data set is not a sample, but is instead a population, all we need to do is change the last letter of our formula. Instead of STDEV.S, we'll use STDEV.P, where P stands for population. Select your data set, close your parentheses, press enter, and there you go. You've got the standard deviation. If you wanted to get a variance instead of a standard deviation, And again, with variance, we need to specify whether we're working with a sample or a population, because of course we won't get the same number in those two scenarios. If you want to get the variance, you can do it in one of two ways. The first option would just be to square your previous result. So I could take my standard deviation if it was a sample, and I could square it. And in Excel, you square by using the caret, which is Shift and the 6 key there, and then you type the number 2. So that's the exponent function, and then the number 2. And so I get the variance for the first, for the set of data, if it's a sample, is 145.942. If I click and drag down, you'll see it's now referring to the second standard deviation. And the variance of the set of data, if it's a population, is 143.4. But what if you hadn't previously calculated the standard deviation? Do you need to do that first and then square it to get the variance? And the answer is no. In Excel, there is a variance command, and it is VAR.P or VAR.S. So VAR for variance, and then .S if it's a sample of data. Select your data, enter, and you'll see I got the same result there. And VAR.P if you want the variance of a data set that is defined as a population. And there we go. And same result as previously. So really quick and easy to calculate variances in Excel. The other one that you might be interested in, of course, is a mean absolute deviation. And you know, that's like calculating a variance or a standard deviation in some ways, except instead of squaring the values, you take their absolute values. So you calculate all the deviations from the mean, you take their absolute values, you add them together, and then you divide by n, or in other words, you average all of the absolute values of the deviations, hence mean absolute deviation. But in Excel, we don't use the word mean to find averages, we use the word average. And so in Excel, the command for the mean absolute deviation is the AVEDEV, average deviation, AVEDEV. So I'll type AVEDEV, AVEDEV, and then select my data set there and press enter, and I've got my mean absolute deviation. Apologies, I didn't label that, so let me just cut it and I'll paste it over here, and I'll just type in there that this is the mean absolute deviation. Okay, so maybe I'll write the words out since we don't use this one as commonly. There we go, mean absolute deviation. We can also get other statistics, other measures of central tendency in Excel. So say we want to get the median. The median in Excel, well, it's really easy. Average was the command for the mean. For the median, it is the word median. Type the word median and select your data, and Excel will return to you the median of that data set. The mode is easy, but you've got to be a little bit careful. In Excel, there's a mode command, but you'll notice that the mode command there is actually out of date here. It says it's available as a legacy function, and that's because if you choose the mode command, it only finds a single mode, if one even exists. I should actually type the word mode here. Let me just do mode. There we go. So if I were to select this and I go and I select all of the data there, Excel will return to me a mode of 32, saying that that's the most frequently occurring observation. But it might not be the only mode. I have no way of knowing. And so we also have another command called MODE.MULT built into Excel, and then there's also a mode. I think single or sing in there. Let's take a look here, and it'll tell us. So we've got mode.mult there, and yeah, mode.single with like all the vowels removed, in order to get Excel to look for just a single mode or to look for all modes that it might find here. Now, with mode.mult, it is actually an array function, which means you should select more than one cell. So kind of select like a few to allow for the possibility that there's more than one mode. If there are, it'll just start filling them up. And it'll stop when it runs out of modes. If it goes all the way to the end, try it again, expanding the selection, because you don't know if it stopped because it found all the modes or if it stopped because that's how many cells you selected. So I'm going to type mode.mult in here. And, I forgot my T there. And I'm going to select my data set. and close parentheses. And then I'm not just going to press enter. I'm going to press control, hold it down, shift, hold it down, and enter. And you'll see Excel fills it in. It says there's actually 3 modes to this data set, 32, 26, and 45. And then it gives me these NAs, not applicables, telling me that it wasn't able to find any more modes beyond that. So these are the 3 modes. Notice it doesn't tell me how frequently they occur. Now, if you were following along and you didn't do the directions quite in the way that I specified, in other words, if you selected a single cell and you just pressed enter instead of control, shift, and enter, it actually likely still will have worked. So let me give that a try right now, and we should see that it should still work for me, hopefully. So I'll type, I don't know why I keep forgetting the T there, MODE.MULT. I just clicked on a single cell this time. I'm going to select all of these values here, close parentheses, and press enter, and you'll see that it did find the same 3 modes, 32, 26, and 45. Notice that it outlined them in blue. And what's happening here is that this is an array function, and it tried to return values into a single cell, and it couldn't. It said, oh, I need 3 cells to report this output. And so it overflowed, and the blue is outlining the overflows there. And you can see it kind of when I click, like if I click here on the ones I entered before and you look up in the address bar, you'll see like we've got mode.mult, and before I actually clicked on it, you could see there was some curly braces around it telling us that it was an array formula. Over here, when you look at these guys, you'll see that, well, I can't show you now because it's finished. They were originally grayed out. Now they're all just filled. There we go. Now they're grayed out. So you can see the actual one is entered here in the first one, and the other 2 are grayed out because they're overflowed. Now that'll work just fine, provided you have a new version of Excel. And I think everybody here is probably using Office 365 because you get it for free as a student, at least while you're a student. And if you're using Office 365, this will work. But if you are using an older version of Excel, I think it's prior to 2018, it will not work. So if you're using like Office 2016, for example, which I think was the last major update before that, you will have to select multiple cells like an array, and you will have to press Control, Shift, and Enter for it to work properly. So just kind of a little warning about that, that you can be quote unquote sloppy and just click a single cell and enter the mode.mult formula and press enter and allow it to spill over in that way, but it won't work kind of reliably. Oh yeah, that's right. I can't delete those because those are part of the array. Okay. Anyways. Moving on here, suppose we want to calculate, I think we've done all of kind of the core statistics that we had there. I didn't, yeah. We've done all the core statistics that we had there, but we didn't talk about the geometric mean. So we can do that. And the geometric mean kind of in its default is just the, we just take the product of our numbers and then take them to kind of the power of 1 over however many numbers we have, right? So like I can take the geometric mean of this entire series if I like here in Excel by using the function GEOMEAN. And what it'll do, it'll just multiply all the values together and then take them to the power of 1 over 58. And it failed. It didn't succeed. And the reason it didn't succeed is because it's just too many darn numbers, and it started calculating it, and the product of those likely overran what Excel is able to handle in its data bank. So let's try it on a smaller set and see if it works there. So I'll just put a set here. Let's do 2 and 15 and 0.5 and I don't know, 11 or something like that. And let's take the geometric mean of that and see if it works for us. And there we go. Excel could handle the geometric mean of those numbers. So it was just too much. We were just asking too much of it to multiply all of these things together, and then take that to the power of 1 over 58. Just couldn't quite handle it. So we can calculate a geometric mean like that. If you are working with like percentages, so you've got like a bunch of growth rates and you need to determine what the average growth rate is, you will still need to add like 1 to them. So if you've got like an account where you earned 5% in the first year and 10% in the next year, and then -4% in the year after that, and then positive 8% the year after that. And there's compounding going on here, and you want to find out what your average rate of return over those years is, then you can't just take GEOMEAN of this. It won't give you the right answer. In fact, it may return an error to you depending on exactly how many terms you have, because you've got this negative in there. So what you need to do, of course, is just like you did when we were solving it by hand, is you add 1 to them, or 100% first. So add 1 to all of them, then take the geometric mean of the numbers, and then subtract 1. Okay, and I don't know why it's showing me so many decimal places. It's a bit ridiculous. If you want to hide those, just make sure you're on the Home tab. Go to the number grouping in the middle here, and then just press this button here to reduce the number of decimal places that are being shown. So we can see that that's 4.609% is the average growth rate of these series. Again, remembering that that's a geometrically growing series, so we have compounding going on in it. If you just had 5 growth rates on like 4 different assets, for example, I don't know why I said 5 different growth rates. You had percentage growth rates on 4 different assets, then you would take the arithmetic mean, because there's no compounding going on between them. So key thing here is this is a time series where you've got that compounding. We've got the geometric mean there. Another thing we might want to do is find percentiles, and Excel makes it really easy to find percentiles. There's actually a percentile command. So what I'm going to do here is just in a blank cell, type equal to percentile, and you'll see there's 2 options. There's Percentile.EXC and Percentile.INC, exclusive and inclusive. The one you want is EXC. That's the one that's consistent with the way that we calculate percentiles in this course and in most applications as well. So Percentile.EXC, and then it asks you to put in an array. An array is just where all of your data are. It's columns or rows, or kind of a combination like a matrix, including all of the data. So select all of those, and then you need to tell Excel what percentile you would like. So say, for example, that I want the 50th percentile, which we know is the median. I'll put in 50% here and press enter, and it returns to me 26. We can compare that with the median we found earlier, which was right over here, and you can see they're the same number. So this is, I'm just going to type the word percentile next to this, and we can easily change that to any other percentage. And so what I'll do here is just go back to the cell and just change the percentile to whatever you want it to be. So if you want like the 33rd percentile, you can type 33% in there. And Excel tells you that the percentile is 21. The 33rd percentile is 21. Or the 95th percentile, type 95% in there, and the 95th percentile is 45, and so on. If you wanted a quartile, obviously you could go ahead and you could type in 25%, and that would give you the first quartile, just like the median was the second quartile. But there is actually also a quartile command in Excel. So if you wanted to find the first quartile, you would use Quartile.EXC. I should do this over a cell. Let me just type the word quartile in here. Quartile.EXC, and I'll select my set of data one more time. Type 25% in there, and not 25%, excuse me, 1. I'll type 1. Notice that Excel guides you with what you need to put in there. So after the comma, it says I'm looking for a quartile, and when you type that, it says if you put 1, it'll be the first quartile. If you put 2, it'll be the 50th percentile, or the median value, or the second quartile. If you put 3, it'll give you the third quartile, which is the 75th percentile, right? So it tells you exactly what you need to put in. So if I want the first quartile, just type the number 1, and you see we get 18 again. So we can calculate that quartile as the 25th percentile or the first quartile, doesn't matter. So Excel also makes that process really easy for us. Now let's suppose that we wanted to create a frequency distribution from this data. And this is going to be a little bit of a process. Obviously, the first thing we need to do is figure out how many class intervals we'd like to have. We've got a total of, 58 observations. So the 2 to the power of k rule would suggest that we should use, I think it's 6 classes, right? And we can confirm that. Let's find 2 to the power of 6. and just confirm that. So I'll go here and I'll type equal to 2. And you remember from earlier that the exponent is shift and 6 for the little caret. And then the number 6 is 2 to the power of 6. That comes out as 64. So that is indeed the smallest power of 2 that is greater than our sample size n, which was 58. Just for reference, if you want to find the sample size, you can type in a cell the word count and select all the data, and it'll tell me that I've got 58 data points there, or 58 observations. Okay, knowing that I want to use 6 classes, I'm going to say k is equal to 6, and I'm not going to be fussy about really setting this frequency distribution up really carefully or anything like that, because the point of this is to show that we can make a frequency distribution, not to worry too much about getting a good frequency distribution. So what I need to do next is come up with some class intervals. So I need to find the range of my data, right? So I'll find the range, and in Excel we can find range using the command max to get the largest observation and min to get the smallest observation. So you'll see that I've typed in here max and selected my data range, and then I've subtracted off. It's really hard to see there. There's a little minus, and then min, and I've selected the rest of the data, and Excel tells me that the range is 45. And so the minimum interval width will be 45 over 6. It's going to need to be a number greater than that, or at least not, specifically greater than that, 7.5. So let's just say, let's round up to 10. So I'll round up to 10. So I'm going to choose, choose the interval width that I'll use is 10. And I still need to figure out where to start. So I want to find the lowest value. You could use the min command to find that, but also I can see here that the smallest value is 0. There's no negative numbers, but there is a 0. So that's where I'm going to start. I'm going to say that I'll go from 0 up to, I guess, up to 60, right? So what I'm going to do here is I'll write 0 up to 10 and 10 up to 20 and 20 up to 30 and 30 up to 40 and 40 up to 50 and 50 up to 60. There we go. Just fix that. But what I really actually want is these just as numbers without the text in there. So I'm going to go 0 and then I'm going to click over here equal to this value plus 10. And instead of using 10, actually, I'm going to click on the interval width there because that would allow me to easily change it to other numbers if I want to. And I'm going to take this last reference here and press F4. That puts this little $sign in front of K, little $sign in front of 12. That turns us from what's called a relative reference into an absolute reference. And it means that when I click and drag the formula around, it will always still refer to K12. It won't move and be referred to K13 or L12 or something like that. It'll always be K12. Then I'm going to go down to this next cell and type equal to and click on the upper limit from the previous cell. And then I'm going to take this and drag all the way down to the bottom. And I'm going to take this and drag all the way down to the bottom. And you'll see that what I've got here now is 0 up to 10, 10 up to 20, 20 up to 30, 30 up to 40, 40 up to 50, and 50 up to 60. And I'm going to, I think, end up with an extra empty class that I don't actually need because I rounded up so much from 7.5 all the way up to 10 and started right on the minimum of the data point there, right? The smallest data value was 0, and that's exactly where I started at. So this one I'm not going to end up needing, although we'll see that in a moment. So then I want to get my frequencies. And so maybe what I'll do, I'll move these over here just a little bit. Let's move them over there. And I'll do my frequencies right next to it just so that we get a nice looking table. Let's cut this and paste it down another row. Just give us a little more space to work. So I'll do the frequencies, the frequency of x, so f of x there. And for this, I'm going to use COUNTIF functions. So I'll type the words COUNTIF. And then inside that, I'm going to choose a range, and the range is going to be where my data are located. And this is also going to need to be an absolute reference because I'm going to drag down. And then in here, I need to put some criteria. And the criteria are going to be that I want to count if it's less than, and I'm going to put that inside a double quotes here, less than, ampersand, and then I'm just going to click on this upper limit that I had here, the 10 that I put down, and I'll close my parentheses. So this COUNTIF command, the double quotes and the ampersand thing is just kind of syntax that you just sort of have to know. It's just the way it works. But essentially what I'm doing is saying count anything that you find in this range, count how many times you see numbers less than whatever the value in 015 is, and that's 10. So how many times do you see numbers less than 10? I press enter and Excel returns to me the value 7, right? Now this is fine because there's no values smaller than 0, but like what if there were? Well, I'd want to check for that. And so what I'm going to do is actually just copy the formula that I have in here. And I'll go up to the formula bar up top here for entering this, and I'm going to go minus, and I'm going to paste the same formula back in there. So now I've got a duplicate, and if I were to press enter, it would just give me 0 because I'm counting the numbers. I find there are 7 numbers less than 10, and then I subtract off the 7 numbers that are less than 10, but that's not actually what I want to do. I'm going to go here, and I'm going to take this cell reference 015, and I'm just going to slide it one place over to the left here. Okay, and Excel's not letting me click the right one there, so I'm going to actually type it in by hand. But basically, I want to move it from column O to column N. It's a little hard to see because the text happened to go right over it, but I'm going to take N15, and I'll press enter, and you'll see what's happened here in just a second. So what this is doing, it's counting all numbers that are less than, let's make this really big just so we can actually see there. There we go. Okay, so this first part's counting all numbers that are less than 015, which is 10. The second part's counting all numbers that are less than N15, which is 0. It finds that there are 7 numbers less than 015 and no numbers less than N15, and so it just returns that as 7 minus 0 equal to 7. Then I can just click and drag this thing down, right? The next one's going to count all the numbers that are less than 20. That's the first part here with 016 in it. And the second part will count all the numbers less than 10, which would of course be the 7 from previously, and then it's going to take the difference and return 11. So it's going to count and populate all the way through. You can see I don't need my last column here or my last row here, right? But I do, because I set this up in this way, I could easily change this to other values. Like I could put in here, for example, 8, and you'll see my class limits over here will update, and you can see all of the different values that have been counted here. Good idea to include a total row so that you can make sure you haven't lost any observations. So you can total up by using the sum command. That's addition. So equal to sum, select all of the class frequencies and press enter, and you can see all 58 data points are still there. So this makes it really easy to play around with different sizes. So you can see, like if I go down to 7, for example, oh no, now I've lost some observations because I've only got 51. So that's no good. If I go to 7.5, oh, I typed that in the wrong spot, excuse me. Go to 7.5 here. You'll see I've still lost some observations because I do have some, apparently several, that are equal to exactly 45, right? If I change this to 7.6, now it'll have all the data points in it again, but I've got these kind of ugly looking class intervals. So you can set it to whatever you want in order to get all the values in there, but you do kind of need to play around with it a little bit. So I'll go back to 10 just because. Now, just sort of for curiosity's sake, if you want to set these up so that they automatically update, you can do that. You just need to use a concatenate sort of function. So I'll show you how to do that just sort of for your own interest. If you go here and you type in equal to, and you click on the lower limit of the first cell, then you press ampersand, and then you're going to use double quotes and put a space, the word up, space, the word to, space, double quotes, ampersand, click on the 10. What we've just done is we've put in a cell reference, and then we've joined it or concatenated it with a text string. And the text string is the part that's inside the double quote. So Excel says, oh yeah, I know that that's just a thing. I don't need to do anything with it. And it's just gonna stick it with the cell references that I have there. So it's going to take the value it finds in N15, which is the number 0. Then it's going to, the ampersands here tell it that it needs to concatenate. So it's going to say, okay, take the number 0 and then just stick to it this text string up to, and then stick to it the number from 015, which is 10. And so it'll go 0 up to 10. And then if I were to kind of delete these and drag down, you'll see that it now fills all the rest of these things in. And I can change these to whatever I want them to be, right? So now if I change the interval width to, say, 9, you'll see that the class limits also update. So you've got that ability to make kind of the whole thing update for you pretty easily, which is kind of cool, I think. I'm going to just slide these over to the left so that it's a little easier to read. We'll move this over to the center. There we go. And we'll call these class intervals. Okay, that's all well and good. Now that we've got this all set up, I'm going to paste it as values. Let's move this over to the left there. There, that looks prettier. I'm going to paste it as values so that I can delete this because I want to work over here for a little bit. And I don't want my class intervals to get all messed up. Actually, you know what? No, I'll keep these. I'm going to need these. So we'll just cut them and paste them over here a little bit. I'm just going to kind of shrink this down so it's a bit easier to see what's going on. Okay, so let's move those down one space. There we go. Let's suppose that we want to construct a weighted mean for a grouped data set. So we've grouped our data here, and let's suppose this is all we had access to, and we want to construct a weighted mean. We can do that in Excel in kind of one of two ways. There's a very intuitive way that takes a little bit longer, and then there's like a really actually pretty quick way that we can get done a lot faster. So the intuitive way, of course, what we need is the class midpoints, right? So we can go here and we can say we'll do the midpoint calculation, and the midpoint is the average of the class endpoints. So we need to take the lower limit, the upper limit, add them together and divide by 2, or we can just use the word average. So take the average, select the midpoints, which is why I decided to save them because I had them written out there. So I'll select the average, and you can see the average of the first class limits. So the midpoint of the first class is 4.5, and I can just click and drag down, and now I've got all my midpoints there. I've also got all the frequencies here, and so I can, let's center those two actually. I can take those and I can multiply them by their midpoints, like we would if we were doing this by hand. So I could take the frequencies and then multiply them by the midpoints by just clicking on the first frequency, and the asterisk is the multiplication symbol in Excel, and then clicking on the midpoint and then dragging down. And then if I wanted to find the weighted mean, well, then I would add all those up, right? And then I would divide by 58. So I can find the weighted mean, the frequency weighted mean of this data set by taking the sum of all of these numbers here divided by that number right there, where there's 58 data points, or the sum of all the weights, sum of all the frequencies. And so I have a weighted mean of 26.4, and you can see it's pretty close to the mean of the actual original data set there, 26.4 and 25.66, or 25.7. So not a terrible calculation to do that way. You could get there a little bit faster. If you've already calculated the midpoints, you can kind of skip this step by using a special command in Excel called the sum product. So if we wanted to do the weighted mean in a single, not a single go, but pretty close, we can do sum product. Sum product is going to take two arrays of data, usually two columns, and it's going to multiply each observation by the matching observation in the other column, and then it's going to add them all together. So if I take the sum product of this column with this column, then what it's going to do is go 6 times 4.5, 7 times 13.5, 17 times 22.5, 16 times 31.5, 8 times 40.5, and 4 times 49.5, and then add all those together, which is the numerator of the weighted mean calculation. And then I can divide by the total number of observations. Now, obviously, we could click on the 58, or if we didn't happen to have that handy, we could sum up all the frequencies, and that would be our weighted mean. So that's pretty quick and easy. It is actually possible to get around having to do this as well using an array formula. But at that point, I think we're starting to get into, if you like, conciseness at the expense of ease. In other words, yes, you can do this calculation all in a single cell, but it's trickier. It's easier to make a mistake. So there's kind of a sweet spot, if you like, of not doing too many extra calculations and spreading stuff out too much, but also not trying to condense it down into a really tiny space and then getting relatively complex formulas that you have to write out. If you wanted to find the weighted variance and then also the weighted standard deviation, then that's pretty easy to do from this point here where you've got the midpoint and you've got the weighted mean. What you can do is find all of the squared deviations, or you can just find the weighted deviations. Well, no, you should square them first, actually. Let me think carefully about that before I talk. So we're going to get these squared deviations. And to get the deviations of each one that you're working with, each result that you're working with, you're going to take the midpoint and you're going to subtract off the weighted mean that you just calculated. And that weighted mean, you want to use it over and over again in each row. So you're going to turn that into an absolute reference. So just highlight Q22 that I had there, and then I pressed F4, or you can like manually type in the dollar signs. It doesn't really matter. But the point is now when I click and drag, it'll always refer back to this cell here, but the other one, the midpoint one, will update as I drag it down. Then I'm going to square that result. So I've got this, the deviation is 4.5 minus 26.38, and then that's going to be squared. So I'll drag down, and you can see that the blue reference to the midpoint's moving down each time I move down a cell, but the weighted mean, the red reference, is staying in exactly the same spot. Once I've got all of those, I can total it up. So I can get the sum of those squared deviations, right? And then I can divide by, and if this is a sample, I'm going to divide by n minus 1. If it's a population, I divide by n. Let's assume it's a sample, so I'll divide by the sum of these guys, which of course is 58 minus 1. And just be really careful. Excel will follow order of operations, so it would have done the division before it did the subtraction. Of course, we want the subtraction to happen first, so I've added in this parentheses here. So that result there will be the weighted variance. Make that a bit bigger. And if we want to get the weighted standard deviation, all you need to do is take the square root of that previous result. And in Excel, the square root command is SQRT. So square root with all the vowels stripped out of it. And there you go. Now you've got a weighted standard deviation. So, once you've got your grouped data, Excel does make it a lot easier to calculate like the variance of the group data or the standard deviation or the mean than trying to do it by hand. Although it's not terrible with the data editor built into the data editor and statistics mode built into the calculator as well. So, you find the approach that works best for you. So I think that's all the statistics from this unit that are really worthwhile calculating in Excel. You can use Excel to make box plots, but it's really not very good at it. It's not terrible at like a behind the scenes kind of calculation. Like if you select the set of data that I've got here and you go to the insert tab and you go to the middle where there's that charts grouping, and you find in the middle of that one there's one that looks like a histogram, and at the top it's got histogram options. At the bottom it's got a box and whisker plot, so box plots. You can see right away there's a problem. It created two. I need to put all of these into a single column to get it to create a single box plot. So I'll correct that. Let me just I'm going to cut this and paste it down here. And this is going to kind of mess everything else up, or it may have messed everything else up. I'm not sure if my formula is updated. I think maybe they did. Nope, they didn't. So yeah, it messed everything else up. But that's okay, because we just want to show this box plot here really quickly. So I'll insert and go back and select box plot, and now it's creating just a single box plot. You can kind of see some of the problems. The first problem is that it's like it only does a vertical box plot. It can't do horizontal, and sometimes you really want your box plot to be horizontal to save space. You can add axis titles, so you can do that. You need to kind of mess around with a little bit. If you add some data labels, again, the formatting's not great, and there's a lot of limitations in where you can place things and what you can have, but you can see it does tell you the maximum, it does tell you the minimum. It can actually handle outliers as well. It does identify the first quartile, the third quartile, and the median. It also tends to include the mean, which usually we don't include on the box plot, but that's okay, it's there. So, you know, if you actually just wanted a box plot for yourself, it's quick. If you wanted to create something that you'd publish, it's less than ideal because it's very, very inflexible. But yes, you can create box plots in Excel. I'm going to just hit undo a couple of times and put everything back to the way it was. There we go. And I'll wrap the video up with that.